on the ground. Today we are going to talk about this involves dual three-phase equipment designed for optimal performance. There are two types of agreement. Intro and we see it.
Dual equipment refers to devices capable of handling two voltages, specifically 400 volts and 230 volts, like Sterbium or IsoArt. Notably, all diesel equipment falls under dual voltage. And then there are dual equipment that is dual in voltage and dual in wattage. Those are what we call double dual, which would be the Canal tube. The advantage: the Servascan, the Sompo, the Sompo, the Servascan. That is equipment that gives the same power in watts, practically the same, very even, both in three-phase and single-phase. Okay, well, today I want to talk to you about dual voltage equipment, those that have 230 and 400 volts, but do not have the same power in the single-phase socket, have a third of the power of the three-phase one. And I want to talk to you about this because now we have quite a few. Both issues: people having to do some bypasses to connect drone chargers. This type of charger, which as you can see has two plugs, the fact that they have two plugs is good because they are equipment that consume, they are single phase, but they consume more than 16 amperes. So the manufacturer of this charger has done it right, put two connectors of 220. I mean, it's like we have a piece of equipment like this which gives, as I say, 7,500 watts. And I have a drone that draws 16 amps per plug. So I can plug in here and here in single phase and I'll be connecting just fine. But what happens when we want to connect to a fatter team, such as those who are using Sterbium a lot? Let's explore how to create derivations and properly connect such intensive equipment. Ready? Let's dive in. Okay, but before moving on to making a three-phase bypass, we are going to understand how the dual three-phase boxes of three phases that are dual in voltage work. Look, here I have an enlarged picture of the Stelvio dell'IsoArt that are the same. Here I have a three-phase plug. Here I have, in the case of Sterbium, 18,000 watts on each of these blue plugs, which are single-phase 230 volts. The most I can get is 6,000 watts, but just because of the blue plug, this fat one, is that I can get 26 amps, that is those 6,000 watts. This plug supports up to 32, and I'm going to ask you, at most I can get 600 watts out of here. It's 26 amps. In the other two pins, the maximum I can get is 16 amps, which corresponds to 3680 watts. That is, if I want to get more power from here than 16 amps, because I have a machine connected here that consumes those 24 amps or 25, which would consume 4 or 5 or 6,000 watts. Whatever I am consuming here, I will not be able to connect another that consumes the same as this one. So in this case of drones, it is necessary to make the derivation that we are going to show you. I'm going to show you from now on. That is, I also want to get 6,000 from here and 6,006 from here by 318, the maximum I can get here. For that, we are going to make the derivations that I show you below. To remember, do not connect more than 16 amperes in these two that are normal Chucos, because they are protected in these thermals from here that are going to jump, and they are not going to allow us to work here a welding inverter. 30 amps, 32 amps, I won't be able to connect it here. I have to connect it here. If I connect it here, I am heating the plug. heating the thermal, and finally when I ask for that power, it will jump. So without further ado, we are going to learn how to make those shunts so we can get up to 6,000 watt outlets here, which I can't do here. Here I have 3 shots, one is as I say 6,000 and the other 2 are 3680. Venga, seguimos. Is the Stelvio table, for example. This is the Stelvio or Izor table, or one 3-phase would be the same. A 3-phase, I mean a 10 and 1500 turns would be the same. Is it very similar or is it the same as this table that I have here? It is a painting of this workshop work, etc. with its limiters, its protections, etc. But we see that you have a single phase outlet here. Okay, I'm going to put this in because that way we can measure better. Okay, we could imagine that I have one here, but I could have another here that's not on, but we could put it right. Let's see how this single phase is assembled, because all of this, as we see, is 3-phase sockets. This is 3-phase with neutral, 3-phase with neutral. 3-phase without neutral ground and 3-phase without neutral. Well, this socket is taken from this here, from one of these two. We can look at it by placing the tester in ohms. Okay, see, if I make continuity here, 0 resistance appears. Okay, well, if I go to this shot, for example, and measure here, well, I see that there is nothing. It is not giving me anything. Okay, well, let's measure this other one, for example, which would surely be the neutral. Okay, look, this is the neutral. Okay, because I know the neutral is the one on the right. Look, if we look at a peg, for example, this peg is worth, and we measure, we see back here. Here we see that the symbol of the earth, which is this one below, puts N in neutral, okay? And here we have line 1, line 2, line 3. So phase 1, phase 2 and phase 3. The 3 phases plus the neutral plus the ground between the neutral tab. Okay, do I put it or do I put it here? Okay, if I have this peg, here I have the earth, which is what is drawn. So here I have the N is worth as it is here. This would be the 1, the 2 and the 3. Well, between this and this, I can get 2 or 30 volts. Okay, that's exactly what this one has done. The one who has built this box here between the neutral and this one, and let's see what phase it has taken. Okay, now we are going to find out, for example, this we already know that it is a phase. We are going to measure with this one. Well, we see that the tester says that it is not this one. We are going to leave it stuck there and we are going to get another one. Let's not see either. Here it is. Look, this is the phase that it is using. Okay, that is this plug, this single phase, just like if it were in a generator, it is taking out of the neutral, which is this. That is, as it is drawn, as I just drew it here coincidentally, of this plus this is worth. If I have a drone or any equipment that has 2 single phase plugs, I have to place it by building along one of this type, that is placing this connected here. Okay, connected here, and I want to take out another plug. If I put another plug here to plug in the other drone plug, I can't charge on the same line again. Okay, I would have to reach these 2, for example, plus the neutral. Okay, from 2 it's going to be neutral, so I know it's pulling 1, so I pull 2, and here I have 230 volts again. This means that if the generator is giving, for example, 3 and 3, 6 and 3, 900 watts, okay, I here would have 3000 watts or whatever amount it is. Or for example, in the case of this table that we are seeing, which is that of Sterbium. Since it has 18,000 watts here, it would have 6,000 watts. Okay, logically, if I reload the one to get another 230, I would have 3000 in each. I'm not going to take two and I'm back to 6000 watts. I could still put 1/3 single phase outlet with another 6000 watts using the 3+ neutral, and I would be back to 230 volts with 6000 watts. Okay. It is understood that is dual in voltage. It means that in the single phase socket I have the third power, the third total power of the generator.
In the case of the third 18,
1000 watts, 6 by 3, 18.
We continue.
Well, you've already seen it. I think it's very simple. Okay, so nothing. Here I leave you with this website so that if you need more information, remember energy.ts. There you can see these dual voltage and power generators that we have talked about. And what I always say before buying, ask so as not to make mistakes. I know it all rhymes, but it's true. Well, also on the website they are in our contacts so that you can consult us what you need. And one last piece of advice which is also important is that it is forbidden to stop learning.